Here we go. Last video. Look at me staying after school, try to get these things knocked out. Don't say I never did nothing for you. All right. This is our Unit 6, Page 4 test review, the last video of the semester. Let's finish strong here. So on this first one, I got the square root of 25 sevenths. Now, before I jump into the problem, a few pieces of housekeeping here. If I divide two numbers inside of a radical, I'm allowed to split up that radical into two different radicals. All right, so this is a perfectly acceptable maneuver to do here. So here's what I'm going to do. I'm going to take this square root of 25 sevenths, and I'm going to call it the square root of 25 divided by the square root of 7. All right, now, fortunately, if you look up on the top, the square root of 25 is just a 5. All right, so I'll put just a 5 there, but I still have the square root of 7 on the bottom, and that is an issue. We do not like having this radical in the denominator. All right, it makes dividing things very difficult, especially if we have to do it by hand. But a lot of times we round, and we don't like rounding, so it's a lot, it's good math to put that square root of 7 in the numerator. So how do we do that? It's actually pretty easy. With square roots, all we have to do is just look at whatever the denominator is and multiply it on the top and the bottom. All right, so in this particular problem, I get a square root of 7 in the bottom. So I'm going to multiply the top and the bottom by the square root of 7. Now, when we do that, when I multiply fractions, you just go straight across. Now, 5 and square root of 7, those are not like terms, okay? So I can't really combine them, but what I can do is just write them right next to each other as just 5 times square root of 7. But if you look at the bottom, those are like terms. They're both underneath a radical, so you can combine them. You can call this the square root of 7 times 7, which is the square root of 49. All right? And we do that because what is the square root of 49? The square root of 49 is just a regular 7. So I got 5 square root of 7 divided by just a normal 7. All right? And that right there, that is your final answer. All right, so I know it looks like an ugly problem, but that's your final answer. All right. So there we go. All right, let's look at the next one. Square root of 80. So just like when we divided numbers, I said the square root of A divided by B, that's the same thing as the square root of A divided by the square root of B. All right. Turns out I can do the same thing with multiplication. So I could say the square root of A times B is the same thing as the square root of A times the square root of B. Remember, A and B, they're just some numbers. All right, so pick any numbers you want, plug them in. This will work. All right. Now, with the square root of 80, what I'm going to do, I'm going to take 80. I'm just going to find all the factors. All right, so I got a 1 and an 80. I got a 2 and a 40. I have 4 times 20. What else do I have? I have a 5, I think, and a 16. And then 8 and a 10. All right, so those are all my factors. Those are all my factors of 80. And if you look here, 4 and 16, those are perfect square numbers, right? So I could really pick either one of these two when I break up my radical, all right? However, it's going to be much more efficient to pick the bigger of the two square root numbers, all right? So I'm going to break this up into the square root of 16 times the square root of 5. All right, I'm doing that because the square root of 16 is just a normal 4. Square root of 5 is just some ugly decimal. Okay, I have no idea what square root of 5 is, so I'm going to leave it as the square root of 5. All right, so that would be your final answer. Now, let's say I didn't pick the 16. Let's say I went the other route. I went with the 4, square root of 4, and the square root of 20. All right, that's fine. I can still get there. So this square root of 4 turns into a normal 2. I got 2 times the square root of 20. All right, but if I look at 20 now, I got a 1 and 20. I got a 2 and a 10. And then I got a 4 and a 5. Right, and if you look at that one, I still have that perfect square factor of 4. So I can split this 20 up into square root of 4, and the square root of 5, and take that 2 and just bring it down in front. So I got 2 times a normal 2 square root of 5, which gives me that 4 square root of 5, right? So you can still get there. It just takes a little bit longer. So it's definitely in your best interest to pick the biggest perfect square that you can find, all right? A lot of times, you don't even need to list out all the factors. Just divide by those perfect square numbers. Those are numbers you should know. 1, 4, 9, 16, 25. Okay, those are the diagonals on your times table. I'm not going to give you those numbers. You have a calculator. You should be able to find those. All right. Now, on these next ones, I got 2 square root of 15 times 3 square root of 10. Now, on something like this, there's kind of 4 things going on here. I got a 2 square root of 15, a 3, and a square root of 10. All 4 of these are just being multiplied together. So there's no dots between the 2 and the 15, and then the 3 and the 10. You can put one there, it doesn't matter, because we're going to move some stuff around anyways. Look for those like terms, the 2 and the 3. Those are both on the outside of the radical. All right, so those are both kind of your outies. You can multiply those. All right, 2 times 3 is just a 6. Right. The 15 and the 10, those are both on the inside of a radical, so you can multiply those and get 150. Right. Now that 150, see if you can simplify it. All right, so write down your factors of 150. All right, or if you just know your perfect squares, which, come on, you really should, do 25 and a 6. Right. So we have a normal 6, square root of 25, square root of 6. That square root of 25 turns into a normal 5. So we have 6 times 5. Let me see, square root of 6. So your final answer on this one is 30 square root of 6. All right. And let's say you want to check your answer. All right, you can absolutely do that. Pull up your calculator. Let's see what we got here. 30, and then just the square root of 6. All right, I don't know what that is. It's some decimal. All right, 73.48 and some change. Now, just type in the original problem, 2 square root of 15. But be careful when you do this. So get outside of the square root, and then press times, and then do the other one, 3 square root of 10. Right, and we hope for the best. Press enter, and look at that. You got the same exact decimal. All right. Next one. I got 2 times 7 times 21. I don't know what that is. It's 147. 147. All right. Let's see here. What can I divide these by? I can do a 49. And I want to say a 3. All right, so this gives me 2 times the normal 7 times the square root of 3, or 14 square root 3. All right, and that's your final answer. All right. All right, next one. Find the geometric mean between 2 numbers. Remember the geometric mean, you're gonna make a proportion. You're gonna say 3 over x equals x over 12. And then you're gonna cross multiply. So you got 36 equals x squared. Therefore, x equals 6. All right, so find geometric mean, make the proportion. Effectively, essentially, I guess what we're doing is you're multiplying the 2 numbers together and you're taking the square root. So we're saying 3 times 12, you take the square root of that, that's going to be equal to x. 3 times 12 is 36. Square root of 36 is 6. All right, next one. The geometric mean of 5 is between 7 and what number? So this what number, let's go ahead and call that an x. So this one's a little bit different. All right, the geometric mean, this is the diagonal. So if we're making the proportion, we're going to say 7 divided by 5 equals 5 divided by that missing number, right? Because this ends up being the geometric mean. All right, so same idea, cross multiply 7x equals 25. Therefore, x equals 25 sevenths. All right. So what you can do is if you want to confirm that, multiply them, square root it. All right. So what we're doing is we're saying The square root of 7x equals 5. Right? Well, how do we solve this one? We have to get rid of the square root. How do you get rid of a square root? Square both sides. So we have 7x equals 25. And then x equals 25 sevenths. Either one of those is going to get you there. All right. The first way kind of revolves around that definition and uses the proportions that we've been talking about. The second way is, I guess the shortcut. Yeah, I don't have a better word for that. All right, but we are going to be using geometric means in the last few problems here. Not this problem, though. This problem is the Pythagorean theorem. Okay, I have a right triangle, and I know it's a right triangle because I have this right angle here. Now, according to the Pythagorean theorem, a squared plus b squared equals c squared, right? Which one's A, which one's B, which one's C? Well, C is always your hypotenuse. The easiest way to figure out where the hypotenuse is, it's always going to be across or opposite from that 90-degree angle. So this guy right here is your hypotenuse. The other two sides, we just call these the legs. It really doesn't matter which one you want to call the leg. All right. So if I do want to fill it out, maybe I'm going to call this side A. I'll call this side B. I'll call this side C, right? C always has to be the hypotenuse. Don't just assume because you have a variable, it's always going to go by itself. The thing that goes by itself is the C value, is that hypotenuse. Sometimes we call this the leg squared plus the leg squared equals the hypotenuse squared. All right, that's another way to kind of think about it. But let's plug it in. All right, I got 4 square root of 3. Now, this whole thing is getting squared, so I'm going to put it all in parentheses. And if you don't put the parentheses, you will get the wrong answer. All right, you should have, I think, 48. If you don't put the square in there, you're going to end up with like 12. All right, so we just have to be very careful on that one. Yeah, so we got 4 square root of 3, the whole thing squared, plus 8 squared equals x squared. All right. So again, that 4 square root of 3. What does it mean to square something? Remember, well, squaring something is times itself. So this is really 4 square root of 3 times 4 square root of 3. We did a couple of these on the previous couple of slides. That gives us 16. That gives us square root of 9, which of course turns into a normal 3. 16 times 3 gives us a 48. All right. So this guy is 48. 48 plus 64 equals x squared. What does that give us? That's 100, 812. 112 equals x squared. Go ahead and square root both sides. All right, you want to square both sides last. You cannot do this. All right, I see people do that all the time. That's wrong. If you do it before you kind of combine all those numbers, you will get the wrong answer, because if you think about it, you get 2 things on the left side and you only get 1 thing on the right. So you can't square 2 things on one side and 1 thing on the other. That's wrong. So it's a 1-for-1 deal. All right. And then your next step is go ahead and break down 112 if you can. I would try 4 first. You probably do better. Try 16. Yeah. So let's do the square root of 16 and the square root of 7. That equals x. So we got 4 square root of 7 equals x. All right, and that one's done. What do we got next time? Ooh, all right. I gave you guys this one on the very last day here. And every single one of you got it wrong. Yikes. So let's try not to make that mistake again here. It's a right triangle. Let's identify the hypotenuse first. That's this guy. This is c squared, or just c, I guess. We'll call this one A and call this one B. All right. So I have x squared plus x minus 7 squared. That is going to be equal to x plus 1 squared. All right. Now, here is where the mistakes happen. X minus 7 squared is not x squared plus 49. All right, if I did dollar for every time you guys did that, I could retire right now. All right, that is wrong. Remember, what does it mean to square something? To square something means to multiply it by itself twice. All right, so that x minus 7 squared turns into x minus 7 times x minus 7. So I'm going to take the time to go through and write down that extra step. All right, so this is going to be plus x minus 7 times x minus 7. That is going to be equal to, and then guess what? We're going to do it again. X plus 1 times x plus 1. This is a double distribute problem, all right? That x has to go to both terms. That's negative 7 has to go to both terms. Similarly, over on the right side with the green stuff, all right? So that first x squared, the red one, that doesn't do anything. So I'm just going to write that one down. Everything else, on the other hand, though, will. So I get x squared minus 7x minus another 7x plus 49. All right, that is going to be equal to, let's try it again on the right side. So x squared plus x plus another x plus 1. All right. Combine any like terms. It's always a good idea to combine like terms if you can. I have 1x squared. I'm going to add another x squared. That means I have 2 x squareds, or it's not x to the fourth, so be careful on that one, minus 14x plus 49 equals x squared plus 2x plus 1. Move everything over to one side. This will be a factoring problem, so I'm going to subtract all of this stuff. I'm going to minus it onto both sides. All right. So I'm not going to write that down. I'm just going to skip straight to it. So we end up with, what are we going to have here? X squared minus 16x plus 48 equals 0. All right, now we need to factor. X times x is x squared. 12 times 4 is 48. Negative 12 minus 4 more gives us negative 16. All right, so this is the correct factoring. So whenever we factor, that's always the hard part. Don't skip out on the easy part now. X minus 12 equals 0. X minus 4 equals 0. All right, therefore, x equals 12 and x equals 4. And I don't know why that blue box is there. Where do I get that out of there? Go away. All right. Now, we have two answers, and anytime you have two answers, that should kind of raise a red flag. Now, we always say plug it into the original problem. And in Algebra 1, I completely agree. But we have the squareds in there now. And that kind of, ruins the whole plug it into the equation. So we have to take it back even further. Don't plug it into the equation, plug it into the picture. All right, because if I do that, let's look. If I plug in x equals 12, I got 12 plus 1. This has a side length of 13. I have just a 12 up here. And then the left side, I have 12 minus 7. That gives me a 5. All right, so that one checks out. Let's look at the x equals 4. 4 plus 1, well, that gives me a 5. No problem. This is just this is a 4 up top. But if we look on the left side, 4 minus 7 gives us a negative 3. All right, and that means we have a side length of negative 3. And that doesn't make any sense for this problem. All right. So that's just something we have to be aware of. So don't erase the x equals 4. Just put an x through it. It's fine. And that one's done. How many more do these have? 3 more. Okay, we can do it. We're almost done. What do we got here? All right, geometric means. This is going to be kind of the last part. This was kind of a tough section. All right. I know I had some patterns that we kind of talked about. So this first one, it looks like kind of a heartbeat pattern, EKG machine, right? If you want to think about it like that. The definition, really, if we kind of follow the definition in the theorems, basically, if we want to look at this triangle, this x plus 9 segment right here, that's the altitude of the triangle. I know it's an altitude because it's perpendicular. It makes that 90 degree angle there. And the theorem says that the altitude, this x plus 9, is the geometric mean of kind of the segments that it's, chopping in half or that it's creating. This hypotenuse right here, this whole thing is the hypotenuse of that big triangle, and it's getting cut into two pieces. So if I take the geometric mean of those two pieces, it'll equal that altitude. All right, so that's what the theorem says. But if we just like to follow the pattern, just do the heartbeat thing. So we can say 8 over x plus 9 is going to be equal to x plus 9 divided by 18. All right, and that would be the correct setup on this one. Now, we have to cross multiply in this guy, so 18 times 8, that's not right. Yes, it is. 18 times 8 is 144. But on the other side, we have to be careful on this one. Don't let this be you. Someone's going to do this on the test. Don't let it be you. Let it be somebody who didn't watch these videos. X plus 9 times x plus 9, right? Don't just write x squared plus 81, right? This is another instance of that double distributing going on here. So I got 144 equals, I'm going to skip a step in here. This is x squared plus 18x plus 81. All right. Another factor problem, subtract the 144 over. We're going to have x squared plus 18x. I don't know what that is. 81 minus 144. That's a negative 63. All right, so what number is that going to be? Yikes. We have 0, and then in parentheses, x times x gives us that x squared. All right, now, factors of 63. I don't know, 21. 21 and 3. All right, 21 times 3 gives us 63. I'm looking for a positive 18, so I need to make it a positive 21 and a negative 3. All right, so I got x plus 21 equals 0, and x minus 3 equals 0. So I got x equals negative 21, and x equals 3. All right. So let's take it back. Remember, not in algebra. Don't plug it into the equation. Plug it into the picture. Which one of these is going to be no good? And if you kind of think about it, the negative 21 is bad. Negative 21 plus 9 is still negative. I can't have a negative altitude unless I'm going underground. All right, so that one's no good. So the correct answer here is x equals 3. All right. Now the next one. Lots of stuff going on here. So first and foremost, x is an altitude of this base right here. So we could do that heartbeat thing again. We could say 9 over x. 9 over x equals x over 4. Cross multiply, you got x squared equals 36. All right, and then when we square both sides, you got x equals, how about 6? X equals 6. All right, so fortunately, that one was pretty quick. All right, no factoring necessary on that one. So again, that kind of followed that heartbeat pattern, if that's the route we want to go. Now the next one, a little bit more involved. Let's find z. All right, if you notice z is a leg of kind of the big triangle. All right, but if we focus our attention to just the left side, all right, z is a hypotenuse of that smaller triangle. All right, so just like before, we are comparing a hypotenuse to another hypotenuse. All right, so what is the hypotenuse of just kind of the big overall triangle? It's 13. All right, so if I compare the hypotenuse to the hypotenuse, we have 13 over z. All right, but now notice how z is a leg of the big triangle. All right, so z is a leg of the triangle. And then if you look at the 9, 9 is a leg of that left side triangle that we were kind of focused on earlier. So I'm going to compare a leg to a leg. So these guys, these are like the hypotenuse of the triangle, and these are the legs of the triangle. All right, so that's one way to kind of think about this setup here. If you're not happy with that, if you prefer the patterns that we mention, get out of here. How do I erase that? There we go. If you prefer the patterns, then let me show you another way to kind of think about it. All right, so we have the heartbeats. So the heartbeats help us find the altitudes. The other one I've mentioned in class, I'm going to call it a boomerang, right? If you think about a boomerang, we throw it, it comes back, it looks something kind of like that. All right, so if I take this shape and I flip it around, it's going to do something like this. All right, so here's what I'm going to do. I'm going to draw another boomerang. Oh no, what did I just click? I don't know what I just did. Oh well. I'm going to start over here. I'm going to throw my boomerang. All right, and it's going to spin, it's going to come around, and every time I've thrown one of those things, it's never landed exactly, where I've been standing. So it gets close, but not quite there. So I'm going to start here, and I throw it all the way down. It comes around, and then it stops short. All right, so that's kind of my boomerang shape here. So I'm going to take the entire bottom piece, which is 13, and I'm gonna follow that flight path. And I'm going to say 13 divided by z, and then it spins around, and I get z divided by, well, that piece that it stopped short at was 9. All right, so that is the boomerang approach. All right, so we can say z squared equals, I don't know what that is, 13 times 9, 117. All right, 117, Master Chief's number here. So let's go ahead and square root both sides, and I got the square root of 117. Right, that is z. Now, fortunately, we can do that same exact pattern to find y. So let's just turn around and throw the boomerang the other direction. All right, so I got 13 over y equals, let's see here, y over 4. All right, so we got y squared equals 52. So y equals the square root of 52, and I believe that breaks down. Yes, it does. Y equals 2 square root of 13. Oh, that looks bad. Sorry. Let me fix that. Square root of 13. Right, that doesn't look any better. One more problem here. Here we go. Unfortunately, save the hardest question for last, because of course I did. All right. Y is an altitude, so this is going to follow our heartbeat pattern here. So we got x over y equals y over x minus 2. All right, and if you look at that equation, we got x's and y's, and that's always an issue. It's always difficult to solve these types of problems when you have two variables. Now, fortunately for us, we can make a second equation. All right, so let's throw the boomerang and see where it lands. So following that entire flight path here, we have to be careful. This entire segment down here, it's 2x. 2x minus 2. And I know that because it's x plus x minus 2. Combine your like terms, 2x minus 2. All right, so if we're following that flight path, we are going to get 2x minus 2 all over x plus 3. That is going to be equal to, oh man, I did it. This is going to be a factoring problem. X plus 3 over x. Actually, yeah, it will be. Oh, what am I doing? All right, sorry about that. So let's go ahead and cross multiply this. So I got x plus 3 times x plus 3 is going to be equal to x times 2x minus 2. So that's x squared plus 6x, skipping a step in there, plus 9 equals 2x squared minus 2x. All right. Move everything over. I'm going to subtract it all to the right side this time. I'm going to have x squared minus 8x minus 9. That all equals 0. All right. So therefore, what times what is 9? That adds up to a negative 8. All right, well, 9 times 1 is 9, and negative 9 plus 1 is negative 8. So x minus 9 equals 0, x plus 1 equals 0, therefore x equals a positive 9, and x equals a negative 1. Now, which one is not going to be any good? Clearly the negative 1, because I can't have a negative 1 side length. Again, we're plugging into the picture, not the equation. All right, so that negative 1 is out. All right, so x equals 9 is going to be our correct x value. So we can use that. We know x equals 9. So look at this purple equation. I'm going to change it up a little bit. I'm going to say 9 over y equals y over 9 minus 2. Well, hey, that's just 7. All right, so I got y squared equals 63. Therefore, y is going to be equal to the square root of 63. We can, of course, break that down into the square root of 9 and the square root of 7. So we're going to have y equals 3 square root of 7. All right, and since this is a system, why don't we write our answer as an ordered pair? We have 9 and then 3 square root of 7. Just like that. That is the last problem on our review. That is the last problem of the semester. So it looks like the only thing standing between me and your I guess your break is this final. All right, so good luck, good job this semester. I know it's been tough, but you guys all did great, and I'm proud of you. All right, so see you later.